Good morning, everyone. So, before the first term, we had started the chapter continuity of functions. So, we used to check whether the given function is continuous at a particular point or not. So, we had done few questions from exercise 6a, and the remaining were left for after first term examination. Okay. So before we see this question, this is question number 18. Okay, we will try to recall the definition for continuity at x equal to a. So let f be a real valued function. Okay, then we say that function is continuous at x equal to a if limit x tends to a fx is equal to the functional value at a, or we can say that left hand limit is equal to right hand limit is equal to f of a. So now let us see question number 18. So here it says that let a function f be defined by this sin x upon x plus 2 cos x if x is not equal to 0, and fx will be 3 if x is 0. Show that f is continuous at 0. So we have to show that this is continuous at 0. Okay. So see over here. Solution. Given f of x is equal to sin x upon x plus 2 times cos x when x is not equal to 0, and this will be equal to 3 if x is 0. This is given to us. Okay, and we have to check its continuity at x equal to 0. So firstly what we will do, we will find its functional value at 0. So at x equal to 0, f of 0 will be, clearly you can see that for x equal to 0 your image will be 3. Okay, so this is done. Now next what we will do, we will find the limit at x equal to 0. If we get limit at x equal to 0 exactly 3, okay, then this function is continuous at x equal to 0. So now here you can see that for x less than 0 and for x greater than 0, image is decided by this. Yes, so instead of finding left hand limit and right hand limit separately, straight we will find the limit. Okay, so we will write limit x tends to 0, f of x is equal to limit x tends to 0, and in place of fx we have to write this, because x tends to 0, that means x is not exactly 0, x is either less than 0 or greater than 0. So we have to write this. Okay, so we will write sin x upon x plus 2 times cos x. Done till here. Now this can be written as limit x tends to 0 sin x upon x plus limit x tends to 0 2 times cos x. In class 11 you have learned that x tends to 0, sin x upon x will be equal to 1. Okay, so this comes 1, and here you can see 2 is there, 2 is a constant, so and it is in multiplication with this cos x, so I can take this out. Then I am left with limit x tends to 0 cos x. And here you observe that if you put x equal to 0, then cos 0 will be 1. Okay, it's well defined. So we get 2 times cos 0. So that is 1 plus 2 into 1, and that is 3. So therefore what do we observe? We observe that limit x tends to 0, f of x is equal to the functional value okay, at x equal to 0, and that is how much? 3. Hence f of x is continuous at x equal to 0. So the given function is continuous at x equal to 0. Okay. Okay. Next question is question number 19. These type of questions are important. Okay. Removal discontinuity. Like here they are given function fx equal to 2x square minus 8 upon x minus 2. Clearly you can see that if x is equal to 2, then it is not defined. So here they have mentioned that it is not defined or undefined at x equal to 2. Okay. Now what value should be assigned to f of 2, okay, so that this function becomes continuous at x equal to 2. Clear? That means they are trying to say this actually, that it is something like this. You can see that if x is 2, then it is not defined, but if x is not equal to 2, okay, then this is very well defined. So for x equal to 2, what we should put over here? Okay, for x equal to 2, what we should put over here so that this function becomes continuous at x equal to 2. So the question is that only. So what we should put over here? If x is 2, then what we should assign the value for this function so that this becomes continuous. Okay. So let us see. So solution: given f of x is equal to 2x square minus 8 upon this. Okay. Clearly fx is not defined at x equal to 2. Fine. Now when this function will be continuous at x equal to 2, okay, so we know, or you can say f will be continuous at x equal to 2 if limit x tends to 2, f of x is equal to f of 2. Okay. So this function will be continuous at x equal to 2 only if this is satisfied. Okay. So what we'll do, we are looking for this value only. We are looking for this value only because we don't know what would be this value. We have to assign this. Okay. So what we will do, we will find this limit. Okay. And whatever value we get, that can be assigned to f of 2. Okay. So I'm trying to say that I had told you that in this question they have just given you this. They have just given you this, and this is question mark. This should be assigned by you. Okay, this question mark, what we should put over here. So it's very easy. What we will do, we will find the limit of fx at x equal to 2, and whatever value comes, that should be assigned here. Okay, getting it? So I'll just put this as rough over here. I will not rough. This is rough. Okay. So what we will do, we'll find the limit at x equal to 2, and whatever value we get, that should be assigned to f of 2. Clear? So now limit x tends to 2 fx is equal to, here you can see that except 2, okay, except for x equal to 2, for the other values fx is defined by this only. Yes, so we don't have to find left hand and right hand limit separately. Straight we can find the limit at x equal to 2. Okay, so limit x tends to 2 f of x. Now this will be written as x tends to 2, okay, and then 2x square minus 8 upon x minus this. Now if you substitute x equal to 2, then you will get 0, okay, 0 by 0. So if you remember L hospital rule, then you can use that. Otherwise you can do this way. You should try to remove that factor which is making it 0 by 0, okay. So here 2 is common in the numerator, so I'm left with this, and here this much. And next, this x square minus 4 can be written as x square minus 2 square upon x minus 2. And the next step, limit x tends to 2, 2 times x minus 2 x plus 2 upon x minus 2. Done. Limit x tends to 2. Now what we can do is, you can see that we can simply cancel this, okay, because here x is not exactly equal to 2, okay, x is somewhere near to 2. So this x minus 2 is not 0, x minus 2 is also not 0, we can simply cancel. So we'll get 2 times x plus 2. In the next step, if you see that if x is replaced by 2, then you are getting a definite value, okay. So we get 2 into 2 plus 2, so equal to 8, okay. So here you can see that limit x tends to 2, f of x is coming 8. Yes, so what I had told you that here this is what they are looking for. So for this we will simply find the limit at x equal to 2, and whatever value we get, we will assign this as that limit, okay. So you write as f will be continuous, or you can say f will be continuous if f of 2 is equal to 8. Clear? So this is the answer. Now let us see question number 20. So here question number 20 is given this is the function, okay. If x is not equal to 2, then function is defined like this, and if it is equal to 2, then function is defined as a. Now they want you to find what is the value for a, okay, getting it. So they are asking you if this whole this function is continuous at x equal to 2, then what should be the value for a. So let's see. Here we can write f will be continuous if limit x tends to 2, f of x is equal to f of 2. Yes or no? So if you see over here, f of 2 is given how much? See, f of 2, if x is 2, then what is the image? A. So f of 2 is given to you. So we will write limit x tends to 2, f of x is equal to a. So f will be continuous if limit at x equal limit of fx at x equal to is equal to f of 2. F of 2 is already a, so I have put a. Now I'll find the limit at when x tends to a. So here you can see that for any x except 2, the function is defined by this, yes or no? So we will write limit x tends to 2 x square minus 4 upon x cube minus 8 is equal to a. Now see over here, you can see that if you put x equal to 2, then you are getting 0 by 0. Okay, so if you want to use L hospital rule, you can use, okay, we had done in class 11, or you can write like this, x square minus 2 square, and down you can write x cube minus 2 cube is equal to a. And then you can write limit x tends to 2 x plus 2 x minus 2, and here you will get x minus 2 x square plus 2x plus 4 is equal to a. You should remember a cube minus b cube is equal to a minus b, and in bracket a square plus ab plus b square. Okay, so you got limit x tends to 2, and here you can see that x minus 2 cancel, and you are left with x plus 2 upon x square plus 2x plus 4. Now if you put x equal to 2, then you are getting a definite value. Okay, so we can put x equal to 2, so we'll get 2 plus 2 upon 2 square plus 2 into 2 plus 4 is equal to this. So 4 here, 4 plus 4 plus 4. So you are getting 4, and 3 into 4 is equal to a. This implies 1 by 3 is equal to a. Therefore a is equal to 1 by 3. Answer. Okay. Now see the next question. So this is from exercise 6a part B. Okay, so question number 4.1, here it says a function fx is defined as follows. So if x is less than 2 or equal to 2, then function is defined like this, and for x greater than 2, function is defined like this. Now for what value of a will fx be continuous at x equal to 2? So they want you to find the value for a so that this function becomes continuous at x equal to 2. Now here what do we see is for x less than 2 and for x greater than 2, we have two different, okay, we have two different functions, or you can say formula, you can say. Okay, so here you have to consider left hand limit and right hand limit separately. Clear? So let's see solution. F will be continuous at x equal to 2 if limit x tends to 2, that means left hand limit, is equal to right hand limit is equal to f of 2. Okay, so put this as 1. We will find them separately. Okay, find separately. So f of 2 is given by what? If you see, for x less than equal to 2, that means for x equal to 2 we have to use this 2x plus 1. So we'll get 2x plus 1, that means 2 into 2 plus 1. So here we are getting 5. Okay, now we will find the left hand limit. So left hand limit is equal to limit x tends to 2 f of x. This we can write limit x tends to 0, sorry, h tends to 0 f of 2 minus h, limit h tends to 0, and for x less than 2, okay, for x less than 2 we have to use this one. You have to use this one for x less than 2. So here you can see this is 2 minus h, means something less than 2. So we'll get 2 times 2 minus h and plus 1. So here you see that if you put h equal to 0, then you are getting a definite value. Yes, so we'll get 2 minus 0, so you are getting 5. Okay, now we will find right hand limit. So limit x tends to this, f of x is equal to limit h tends to 0 f of 2 plus this. So here you can see that 2 plus h means something bigger than 2, greater than 2. So for x greater than 2 we have to use this 3 minus ax. So 3 minus ax, so we'll get 3 minus a, and in place of x we have to write this 2 plus h. Here what do we observe? If we put x, sorry, limit h tends to 0, and here you get 3 minus a 2 plus h. So here if you put h equal to 0, you are getting a definite value, so write it down. So you get a here 0, so you get 3 minus 2a. Okay, so you got this separately. Now from 1, okay, from 1 we get, so from 1 we get this left, okay, let me write like this, left hand limit is equal to right hand limit is equal to the functional value. So left hand limit we had got 5, right hand limit we got 3 minus 2a, and the functional value we have got 5. So we are looking for value of a, so we can easily write 3 minus 2a is equal to 5. So we will get minus 2a is equal to 5 minus 3. This implies a is equal to 2 upon minus 2. So a is equal to minus 1. Okay, so you got the value for a. Now see the next question. Here question number 13, 2. Here it says if the function fx is given by this, for x greater than 1 it is given 3x plus b, and for x equal to 1 is given as 11, and for x less than 1 it is given 5x minus 2b. They are saying that this function is continuous at x equal to 1. They want you to find the value for a and b. Okay, so as they say that this is continuous, means what? Here left hand limit is equal to right hand limit is equal to f of 1. Here I will consider left hand and right hand limit, because we can see that for x less than 1 they have given separately, for x greater than 1 they have given separately. Okay, and for x equal to 1 we have over here. Done. So see, now you can write f will be, or you can say f is continuous if f is continuous so limit, okay, one second, continuous at x equal to 1. F is continuous at x equal to 1, so limit x tends to 1 from left hand side equal to limit x tends to 1 from right hand side is equal to f of 1. Okay, put this at equation 1. Now f of 1 is equal to 11. Okay, f of 1 is 11. Limit x tends to 1 from left hand side will be equal to limit h tends to 0 f of 1 minus h. So for less than 1 we have to use this 5ax, we have to use, okay, so 5ax, so in place of x we'll write 1 minus this minus 2b. If you put h equal to 0 you are getting indefinite value, so you can get 5a 1 minus 0 minus 2b. So you get 5a minus 2b. Okay, so this is done, and right hand limit x tends to 1 from the right hand side, limit h tends to 0 f of 1 plus h is equal to limit h tends to 0. Now for x greater than 1 we get 3ax plus b, so we get 3ax, so 1 plus h plus b, let me check once, plus b, okay, correct. Now here you see that if you put h equal to 0 you are getting a definite value, so we'll get 3a 1 plus 0 plus b, so 3a plus b. Done. So you got left hand limit, right hand limit, and you have the functional value also. Okay, now see from 1, okay, from 1 what we'll get? From 1 we have left hand limit is equal to right hand limit is equal to f of 1, so we can straight write this. Okay, from 1 we'll get this 5a minus 2b, this is your left hand limit, is equal to right hand limit, that is 3a plus b is equal to f of 1, that is 11. Okay, and from here you are getting 5a minus 2b is equal to one second, you can write 5a minus 2b is equal to 11, put this as 2, and 3a plus b, 3a plus b is equal to 11. Now you got simultaneous equation. Yes, you can solve it. So here, if you multiply this one second, if you multiply this third equation by 2 and then add, then this minus 2 and plus 2 will get cancelled and you'll get value for a. So see over here, I'll write equation 2 plus 2 times equation 3 gives. So here actually I'm multiplying the equation 3 by 2 throughout and then adding with equation 2. So in that case 3 2 just 6 and here 5. So 5a plus 6a, this minus 2b and plus 2b cancelled, is equal to 11 plus 22. Okay, so you got 11 a 33, a is equal to 3. Now you can put a equal to 3 either in 2, okay, or 3. So put a equal to 3 in 2, then 5 into 3 minus 2b is equal to 11. So you will get minus 2b is equal to 11 minus 15. So minus 2b is equal to minus 4. So b is equal to 2. Okay. Therefore, a is equal to 3 and b is equal to 2. Answer. Okay. And with this chapter continuity of function gets over, and in the next class we shall see the chapter differentiability. Okay.